In this series of videos, we are going to talk about radical expressions and functions. We'll be calculating square roots and cube roots and fourth roots and talking about the function of f of x equals the square root of x. So let's start with the definition of square root. So many of us already know how to determine or calculate pretty quickly the square root of a number, especially when that square root of a number is perfect. We've at some point likely used the calculator to help us along on numbers that we're not so familiar. But for the square root, the definition that might help us understand it a little bit more, if we have a number and we square it, and we call that squared number b. So if a squared equals b, then a is equal to the square root of b. So like multiplication undoes division and division undoes multiplication, how those are inverse functions of one another, the square root is the inverse of squaring. So here we have squaring, and right below it we have square rooting. And it's a little bit easier to see with real numbers. So I'm going to put this into perspective with some numbers that we can feel comfortable with. If I have 3 squared equals 9, then 3 is equal to the square root of 9. And now we're going to talk about the principal root. The principal root of a square root is always positive. So if you go over to your calculator and you were to put the square root of 9 in, your calculator would give you the value of 3. If you were to put the square root of 25 in, your calculator would give you 5. It would give you one answer only, and that would be the positive principal root. So let's practice that. And the only time you're going to get a negative is when the problem or the expression dictates that it's a negative. For example, I have the square root of 25. The square root of 25 is equal to 5. If I put that into my calculator, the square root of 25, yesterday, today, tomorrow, will always give me one answer, and that answer is the principal root of 5. The square root of 25 over 64. What times itself is 25 over 64? 25, I apologize for that. The square root of 25 is 5, and the square root of 64 is 8. So the fraction that multiplies by itself to equal 25 over 64 is 5 over 8. And you can think of it as the square root of 25 over the square root of 64. Now the next one, we have a negative on the outside. We have a negative on the outside. So this negative on the outside is going to turn whatever the square root of 64 is, it's going to take the opposite of that value. So the square root of 64, we know is 8. 8 times 8 is 64. And then this negative comes down and says that your answer is going to be negative 8. So this negative in front of the square root says we want the negative root, not the principal root. And then the square root of a decimal. The square roots of the decimal always make me nervous. Fractions I love much better. For instance, this fraction right here, love that. This decimal right here freaks me out. So how do we do this problem? I change it to a fraction. So I've got the square root of 49 over, this first place is the tenths, 100ths, 1,000, 10,000. So this is going to be 49 over 10,000. And the square root of 49 is 7. And then the number times itself that equals 10,000 would be 100. 100 times 100, that would be 2 zeros. Times 2 zeros would give you 1, 2, 3, 4 zeros. So 7 over 100. And then they probably want this back in decimal form. So 7 hundredths is 0.07.